Hello, hi everyone. Welcome to the student brand. This is your Shiva sir. Hello, hi everyone. Welcome to the student brand. This is your Shiva sir. Today we are going to discuss about light reflection and refraction chapter. Light reflection and refraction. So here I'm taking the plane mirror. This is the plane mirror. Okay. So incident light ray. The light which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. Okay, so incident ray, I'm taking this incident ray and reflected ray, and the line which is perpendicular to the plane surface, that is called normal line. The line which is perpendicular to the plane surface is called normal line. Okay, so I'm taking this a normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And we can see here this undeviated line, the angle between reflected and undeviated line is called angle of deviation. Angle of deviation. Now you can see here the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Okay, so the bouncing back of the light from the reflecting surface is called reflection of light. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Right? Yes. So now laws of reflection. Laws of reflection. Laws of reflection. First one you are taking. Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Once again, laws of reflection. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. So coming to this one, here linear angle is 180 degrees. Linear angle is 180 degrees. Linear angle is 180 degrees. So that's nothing but angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, so now we can take, so we know from laws of reflection, angle of incident is equal to angle of reflection. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Okay, now you can see angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear to you all. Just check once. Now Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. So now the linear angle is 180 degrees. Linear angle is 180 degrees. Angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incident plus angle of incident plus angle of deviation equal to 180 degrees, because in the place of angle of reflection I'm substituting angle of incident, so that's why angle of incident plus angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Okay, so this is about reflection, uh, reflection phenomena, loss of reflection and angle of deviation formula, right? Yes. Now we can discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. So coming to regular reflection and irregular reflection. So regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. So regular reflection takes place on smooth surface, irregular reflection takes place on rough surface. Okay, so I'm taking the plane surface. So this is the plane surface, plane surface. So here incident light rays are parallel. Incident light rays are parallel. Then reflector light rays are also parallel to each other. Incident light rays are parallel. Then reflector light rays are also parallel to each other. Then this type of reflection is called regular reflection. Incident light rays are parallel. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. So I'm taking, these are the incident light rays. Incident light rays. Okay, so these are the reflector light rays. Reflector light rays. Now you can observe incident light rays are parallel to each other, then reflector light rays are also parallel to each other. Incident light rays are parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Regular reflection. Okay. Regular reflection. Regular reflection takes place on smooth surface. Regular reflection. Regular reflection takes place on smooth surface. Coming to irregular reflection. So I am taking irregular reflection here. Irregular reflection. Irregular reflection. Okay, so here. So incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Okay. So incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Okay. So for example, you can take wall, paper. So wall, paper. So this type of examples we can take irregular reflection. Coming to regular reflection takes place on smooth surface, still water, you can say still water and plane mirror, whereas irregular reflection on rough surface, wall, paper, we can take, right? Yes. So this is about regular reflection and irregular reflection. Regular reflection and irregular reflection. Now, object and image. So you can see here, this is a plane mirror. So here I am considering the real object. So light rays are coming from here. Okay, after reflection, the light rays are moving away from it. Okay, so these light rays are moving like this, and here also. If you are extending those light rays, so those light rays are meeting at one point here. Virtual image, real object and virtual image, real object and virtual image, real object and virtual image. Real object and virtual image, real object and virtual image, real object and virtual image. So one more. So here I am considering like this, light rays are coming from infinity. Light rays are coming from infinity after reflection. If we are extending the incident light rays, those incident light rays are meeting at one point. Okay. So here you can see, this is the real image and a virtual object, real image and virtual object, real image and virtual object. Now you can observe. So here from this point, light rays are coming after reflection, those are moving away from it. If you are extending the reflector, extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That's a virtual image. So here, reflector light rays, directly reflector light rays are meeting. Directly reflector light rays are meeting. Their image is forming. That is a real image. If you are extending the incident light rays, extended incident light rays are meeting at one. Their virtual object is forming. Extended incident light rays are meeting, their virtual object is forming. I hope it is very clear, right? So virtual image and virtual object. Now see here, object and image. Object is real, image is virtual. Object is virtual, image is real. Okay, so once again, observe carefully here. Object is real, object is real, image is sorry, object is real, image is virtual, object is real, image is virtual, image is real. I hope it is very clear about it. Once again, so real object and virtual image, real image and virtual object. So object is real. Object is here is real. So image is virtual. Object is virtual. Image is real. Image is real. So by seeing these two diagrams, by observing these two diagrams, we can conclude that real object, virtual image, real image, virtual object, real image, virtual object. Yes or no? Yes. So this is the table. So we can follow that one. I hope it is very clear, right? Next. Nature of the image formed by the plane mirror. So we'll discuss about nature of the image formed by the plane mirror. We'll discuss nature of the image formed by the plane mirror. Right? Yes. Hmm. Now, nature of the image formed by the plane mirror. Okay. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So that's why I'm taking like this, one light ray and another light ray. So here listen carefully. Object is real, image is virtual. AB is the object and A dash B dash is the image. AB is the object, A dash B dash is the image. So now first point is object is real, image is virtual. Object is virtual, image is real. Coming to the second one, second one is okay. So object distance is equal to image distance. So the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Once again, the distance between object to mirror is called object distance. The distance between mirror to image, object to mirror is object distance. The distance between mirror to image is called image distance. Image distance. So object distance is equal to image distance. Coming to the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Coming to the fourth one is magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And coming to the fifth one, that is fifth one is it also shows lateral inversion. It also shows lateral inversion. What is a lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this is called lateral inversion. Lateral inversion. lateral inversion. So once again, coming to the plane mirror, nature of the image formed by the plane mirror. Object is real, image is virtual. Object is virtual, image is real. Vice versa. So object distance is equal to image distance. Height of the object is equal to height of the image. Magnification is +1. And it also shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object happens to be left side of the image. Left side of the object happens to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Lateral inversion. Okay. So this is about object and image. Object and image. Now we will discuss about spherical mirrors. Spherical mirrors. The mirror which in the form of curved shape. The mirror which in the form of curved shape is called spherical mirror. Depending on the reflection of light, there are two types of spherical mirrors are there, concave mirror and convex mirror. Concave mirror and convex mirror. So now we will discuss about spherical mirrors, right? So start with the spherical mirrors. Okay. So if you are taking small portion, that is called curvature. Small portion is called curvature. Okay. So this entire sphere, the small portion is called curvature. Curvature, that is spherical mirror. Reflection takes place inward. Reflection takes place inward is called concave mirror. Reflection takes place outward is called convex mirror. So reflection takes place inward is called concave mirror. Reflection takes place outward is called convex mirror. So we'll discuss now. Now you can see here. So concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror or converging mirror. Converging mirror. Convex mirror. Convex mirror is also known as diverging mirror. Sir, why you are saying concave mirror is converging mirror, convex mirror is diverging mirror? What is the reason? Because whenever the light rays are incidenting on the mirror, after reflection, light rays are moving towards the principal axis. So after reflection, light rays are moving towards the principal axis. That's why it is called concave mirror. That is also known as converging mirror. Concave mirror is known as converging mirror. Whereas convex mirror, after reflection, light rays are moving away from the principal axis. After reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror. Converging mirror and diverging mirror. So after reflection, light rays are moving towards the principal axis. After reflection, light rays are moving away from the principal axis. Converging mirror and diverging mirror. So convex mirror is also known as diverging mirror. Convex mirror are also known as diverging mirror. Diverging mirror. Okay, so next one. Terms related to spherical mirror, we'll discuss terms related to spherical mirror. Terms related to spherical mirror. Okay, so what are those? We'll see. So this is a part of the sphere. This is a part of the sphere. The center of the imaginary sphere in which mirror is a part. The center of the imaginary sphere in which mirror is a part is called center of curvature, and the midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Once again, center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. So first one is center of curvature, second one is pole, third one is the line joining of center of curvature and pole is called line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Principal axis. Principal axis. Okay, coming to the fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. This is called radius of curvature. Or coming to the fifth one, after reflection, light rays are meeting at one point on the principal axis. After reflection, light rays are meeting at one point on the principal axis. So here you can see, after reflection, light rays are meeting at one point on the principal axis, here and here. Okay, so this is called a focus. So we can also say simply focus, or also say we can say principal focus. Principal focus, or simply we can say focus. And the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So this distance is called focal length. Focal length is small f. Focal length is small f. And coming to the seventh one is width of the mirror. Actually, the width of the mirror is, I am taking concave mirror. So this is a concave mirror. Okay, so concave mirror I consider. So this is a concave mirror. Once again, listen carefully. Center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. Line joining of center curvature and pole is called principal axis. Line joining of center curvature and pole is called principal axis. So the distance between center curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point of the principal axis, that is called focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length, and width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror is called aperture. Okay, so width of the mirror is called aperture. So this is about terms related to spherical mirrors. Terms related to spherical mirror. Once again, so center of curvature, pole, principal axis, focus, radius of curvature, focal length, aperture. That's enough. Next one, we will discuss about ray rules of concave mirror. Ray rules of concave mirror. Ray rules of concave mirror will discuss. Ray rules of concave mirror. Ray rules of concave mirror. See here. Ray rules of concave mirror. Ray rules of concave mirror one side and convex mirror. Here I am drawing concave mirror. Here I am drawing convex mirror. So check once. Concave mirror. Concave mirror. And convex mirror. Convex mirror. So concave mirror. First one. So here I am considering the pole, focus and center of curvature. Light ray is coming from infinity after refraction. So after reflection, sorry. After reflection it passes through focus. Second one is so pole, focus, center of curvature. Light ray is passing through focus. After reflection moves towards infinity. Coming to third one. So pole, focus, center of curvature. Light ray is passing through center of curvature. Light ray is passing through center of curvature. It reaches its original path. Retrace its original path. And coming to the fourth one. So pole, focus, center of curvature. Light ray is incidenting at the pole. So it will be reflected back. Light ray will incident at the pole. It reflect back like this. Okay, so coming to the convex mirror. Okay, first one. So pole, focus, center of curvature. Pole, focus and center of curvature. One light ray is coming from infinity after reflection. Moves. So light ray will passes through focus. Second one. So pole, focus, center of curvature. Light ray is passing through focus. Okay, so it moves like this. And coming to third one. Third one is so pole, focus, center of curvature. Light ray is passing through center of curvature, retraces its original path. Light ray is passing through center of curvature. So I am taking here. So it retraces its original path. Coming to the fourth one. Light ray is incidenting at the pole. So this is the pole. Focus, center of curvature. Light ray incident the pole, it reflect back. Okay. So here you can observe one thing. First one is light ray is coming from infinity after reflection passes through focus. Light ray is passing through focus after reflection moves towards infinity. Light ray passing through center curvature retraces. Light ray incidenting pole, it reflect back. Here also light ray is coming from infinity after reflection. So it passes through focus. Light ray is passing through focus after reflection moves towards infinity. Light ray is passing through center curvature, retraces original path. Here light ray is incident the pole, it reflect back. So this is about concave mirror and convex mirror ray rules. Concave mirror and convex mirror ray rules. Concave mirror and convex mirror ray rules. Coming to the image formations, now we will discuss about image formation. Image formations. Now we will discuss some image formations. Okay, so be ready. First one, concave mirror. Concave mirror. Concave mirror. So object is at infinity. First point is concave mirror I am taking. So pole, focus, center of curvature, pole, focus and center of curvature. Object is at infinity. So object is at infinity. So how many light rays are required to form the image of the object? Minimum 2 light rays. So that's why I am taking here. Object is at infinity, image will form at focus. Nature of the image is real and inverted. Nature of the image is real and inverted, and size of the image is highly diminished. Coming to the second one. So pole, focus, center of curvature. Pole, focus, center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. Here I am placing object. Okay, so one light I am taking like this. After reflection passes through focus, another light ray passing through center of curvature. Okay, so the image will form between C and F. Here, object is placed beyond C. Image will form between C and F. Nature of the image is real and inverted. Nature of the image is real and inverted. Size is diminished. Nature of the image is real and inverted, so diminished. Okay, so coming to the third one. Third one. So pole, focus, center of curvature. Object is placed at center of curvature. Object is placed at center of curvature. Image will form at center of curvature itself. Object at C, image also will form at C. Nature of the image is real and inverted and same size. Coming to the fourth one. So pole, focus, center of curvature. Object is placed between C and F. Object is placed between C and F. One light I am taking like this, it passes through focus. Object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Coming to the last second case here. So pole, focus, center of curvature. Object is placed at F. Object is at F. Image also will form at infinity nature, real and inverted, and size of the image is highly enlarged. Okay, so object is at F. Image will form at infinity. Nature of the image is real and inverted and highly enlarged. Coming to the sixth case. Sixth case is very important. Sixth one. So pole, focus, center of curvature. Object is placed between F and P. Here I am placing the object. How many light rays are required? Minimum 2 light rays I said. So one light ray I am taking like this. So it passes through like that. Focus. Another light incidenting at the pole. It reflect back. So image will be behind the mirror. Nature of the image is virtual, erect and enlarged. Object is between F and P. Object is placed between F and P. Nature of the image is virtual and erect. Enlarged. Virtual, erect and enlarged. Okay, so check once. Image is formed behind the mirror. Nature of the image is virtual, erect and enlarged. Okay, so just look at the diagram, just check once. Again I will explain the topic. Okay, now we'll discuss about convex mirror. Convex mirror. Now we will discuss about convex mirror image formations. Only two cases are there. One is object is at infinity. Okay. So one is object is at infinity. So I'm taking here pole, focus, center of curvature. So light rays are coming from here after reflection. Okay, so if you are extending the reflector light rays are meeting at one point. Object is at infinity, image is forming at focus, nature of the image is virtual, erect and highly diminished. Highly diminished because virtual erect object image is formed at focus. Image is forming at focus. Okay, now. Okay, so object is at infinity, image will form at focus. Next one more light I am taking like this, incidenting at the pole, it reflect. Nature of the image is virtual, erect, and diminished. Is it clear? Check once here. Object is at infinity, image will form at focus. Nature of the image is virtual, erect, and highly diminished. In this case, object is placed between F and infinity, image will form between P and F. Nature of the image is virtual, erect, and diminished. Okay, so this is about convex mirror. Now, sign conventions. So we'll discuss about sign conventions. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So like that, New Cartesian sign convention is nothing but so these points are very important. 5 points are there. Okay, 5 points are there. So I am taking the concave mirror here. Concave mirror, converging mirror, concave mirror, converging mirror. So here I am taking pole, focus, center of curvature. All measurements will be taken from the pole. So in the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, it is positive. Below the principal axis, it is negative. Above it is positive and below it is negative. Okay, what are those? So all measurements we have to take from the pole. In the direction of incident rays, all are positive. What are those? Object distance, image distance, focal length, and radius of curvature. Here, object distance, image distance, focal length, and radius of curvature. So above the principal axis, height of the image and height of the object, and below the principal axis, height of the image and height of the object, negative. Okay, so these are the new Cartesian sign conventions, or simply we can say sign conventions. Sign conventions. So once again, new Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant rays, distance are positive. Above the principal axis, distance are negative. Below the principal axis, new Cartesian sign convention, new Cartesian sign convention. Okay, so have a break, 10 minutes break. Now, explanation again. Explanation. So at the rate of now 10:45. So 10:55 I will explain. 10:55 a.m. 10 minutes break. Okay. So until that, stay tuned. Hello, hi everyone. Welcome to the class. This is your Siva sir. So sign conventions completed. Now mirror formula, magnification. Okay, so now mirror formula is 1 by f equal to 1 by f 1 by f equal to 1 by v plus 1 by u. So magnification equal to height of the image by height of the object. Height of the image by height of the object, that is nothing but minus v by u. Okay, so now you can see here mirror formula. Mirror formula is m equal to height of the image by, so mirror formula is this one. This is the mirror formula. So mirror formula. So 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object. Height of the image by height of the object, that is equal to minus v by u. Minus v by u, right? Yes. Now, so we'll go to the next one. Now we will discuss about refraction phenomena. Refraction. So here rarer medium and denser medium. If the light ray is moving from rarer to denser, so at the interference of the two media, it will bend. So it will bend. So if I am taking light ray is moving from rarer to denser, if the light ray is moving from rarer to denser, so here at the point of interference, it will bend towards a normal line. Okay. So the path of the light changes at the interference of the two media is called refraction of light. The path of the light changes at the interference of the two media is called refraction of light. Okay, so the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So same thing if the light ray is passing from rarer medium and denser medium. Light ray is passing from denser to rarer, so it moves away from the normal line like this. So angle of incidence and angle of refraction, angle of refraction, angle of incidence and angle of refraction, angle of incidence, angle of refraction. Now you can see here, in this case, angle of incidence is greater than the angle of refraction. Here, angle refraction is greater than the angle of incidence. Angle of incidence. So what is the refraction? So the path of the light changes The path of the light changes when it is moving from rarer to denser. The path of the light changes when it is moving from rarer to denser, or simply we can say the bending of the light at the interference of the two media. The bending of the light ray at the interference of the two media is called refraction. Is called refraction. So here laws of refraction will discuss. Laws of refraction. Laws of refraction. Laws of refraction. Laws of refraction is nothing but, so incident ray, so refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies in the same plane. Second one is sine of angle of incidence to sine of angle of refraction equal to constant. Equal to constant. That is the refractive index. Once again, sine of angle of incident to sine of angle of refraction equal to constant. I hope it is very clear. Check once. Loss of refraction. Loss of refraction is nothing but incident ray, refracted ray, normal line lies in the same plane. And sine of angle of incident to sine of angle of refraction equal to constant. Constant is nothing but refractive index here. So n equal to c by v. N equal to C by V, that is absolute refractive index. N equal to C by V is absolute refractive index. What is absolute refractive index? The ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Coming to relative refractive index, so I will explain relative refractive index. Make sure that okay, so you are following these points, very important points. So now relative refractive index, we'll discuss about relative refractive index, that is N12, that is equal to N1 by N2 is equal to V2 by V1, because n is inversely proportional to velocity. 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 That's why I'm taking N12 equal to N1 by N2. That is nothing but V2 by V1. So N21 equal to N2 by N1. That is nothing but V1 by V2. V1 by V2. I hope it is very clear. It is very clear. Just check once. Check once. Here I am saying N12. N12 equal to N1 by N2. That is nothing but V2 by V1. N21 equal to N2 by N1. That is equal to V1 by V2. So why? Because refractive index is inversely proportional to velocity. Refractive index is inversely proportional to velocity. That's why N12 equal to N1 by equal to V2 by V1. N21 equal to N2 by N1 equal to V1 by V2. Okay, so this is about absolute refractive index and relative refractive index. Absolute refractive index and relative refractive index. I hope it is very clear. Next one. So now Absolute refract index, relative refract index completed. So now you can see here, if the light ray is passing from rarer to denser to rarer, light ray is passing rarer, denser, medium. This is rarer medium, denser medium. Light ray is passing from denser to rarer. Light ray is passing from denser to rarer. What happens? Normally, light ray is moving from denser to rarer. It moves away from the normal line. Yes or no? If the light ray is moving from denser to rarer, so this angle of incidence and angle of refraction. So what is the refraction phenomena? If the light ray is moving from denser to rarer, it moves away from the normal line. So that is the first condition. So coming to the next one is, so just one example, just one activity will do. So if you are sending light ray from this rarer medium, denser medium, so I am sending the light ray. So one light ray, so again it will passes, again another light ray it passes. So I am keep on changing the angle. So angle of incidence, I'm changing the angle of incidence at a certain angle. So at certain angle, the refracted ray passes along the surface. At certain angle of incidence, refracted ray passes, gauges along the surface. Refracted ray passes or gauges or moves along the surface. So that angle is called critical angle. You can see at certain angle of incidence, the refracted ray passes along the surface. So this angle is called critical angle, or it makes 90 degrees with the normal line. It makes 90 degrees with the normal line. So that is called critical angle. So this is called critical angle. The angle at which the refracted ray passes or gauges along the surface or moves along the surface. So that angle is called. So because of this angle only, the refracted ray passes or gauges along the surface. So this angle is called critical angle. This angle is called critical angle. Now I am sending one more light ray here. So at certain angle of incidence, so the refracted ray makes more than 90 degrees. So 90 plus theta makes more than 90 degrees. Then the light ray will reflect back. Back into the same medium. Once again, listen. So normally what happens if the light ray is moving from denser to rarer, it moves away from the normal line. Light ray is moving from denser to rarer, it moves away from the normal. So here at certain angle of incidence, the refracted ray passes or gauges along the surface or makes 90 degrees with the normal line. So that angle is called critical angle. So here again light ray is passing from denser to rarer. If the light refracted ray makes more than 90 degrees, or more than critical angle, then light ray will reflect back into the same medium. So this is called total internal reflection. Total light internally reflection takes place. Total light internally reflection takes place. Okay, so next one. Now you can observe here. I am taking the glass slab. Okay, light ray is passing from rarer to denser. So I am taking this the rarer medium and this the denser medium. So glass slab. glass slab. So here if I'm taking like this, so I'm taking the normal, I'm drawing the normal line. Okay, so now after refraction it passes, so it bends towards the normal line, so like this. The distance between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift or lateral displacement. Lateral displacement also we can say. Okay, so incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Okay, the distance between emergent ray and initial direction of the incident ray is called lateral shift. Okay, now we can. So I'm taking one beaker here. So I'm considering one beaker. So I placed one coin over here. So I placed one coin. Okay, so the person is standing here. The person is standing here. Okay. So initially, now he can't able to see the coin. Initially, he can't able to. The position will rises up here. Okay. So here, the distance between actual position to apparent position of the coin, the distance between actual position to apparent position of the coin is called vertical shift. Vertical shift. The distance between actual position to apparent position of the coin is called vertical shift. So lateral shift is nothing but the distance between emergent ray to extended incident ray is called initial direction of the incident ray is called lateral shift. So the distance between actual position to apparent position of the coin is called vertical shift. Vertical shift. Okay. And if you place the lemon inside of the beaker also, if you place lemon inside of the beaker also here, so if you are placing lemon, okay, it appears bigger due to refraction of light. Lemon appears bigger due to refraction of light. And so you can place the pencil also. So if you are placing the pencil, so if you are placing the pencil, I am taking here like this. So it appears to be bent. Appears to be bent. So the at the interference of the water and air. So the pencil appears to be bent. The pencil appears to be bent due to refraction of light. Due to refraction of light. Okay, so these all. So these examples they will ask in exam. One is coin placed bottom of the beaker and lemon placed inside of the beaker. And here, so water will be there. So water is there inside of it. And here, so pencil is inside of the beaker also it appears to be bent because due to refraction of light. Okay. So next one, lens. So we'll discuss about lens. Mhm. So every day I'm conducting the test. So test is available. So you can check in the community post. Community post. So test I'm conducting. So 5 questions. So minimum 5 questions I'm giving. Test I'm conducting every day. So you can check in the community post. Community post every day I'll post five questions related to CBSE Grade-10 physics, and grade 11 and grade 12 also will discuss. Grade 11 and grade 12 also. So slowly I will start. So already started grade 11. Grade 11 classes are going on. Grade 12 also will start. So grade based on grade 10, so I'm uploading the questions also, and I you can check once. So website is there. Website is there. So blogger is there. Okay. So you can check once. I'm in the community post. You can check once. In the community post, you can check once. Right? Yes. So now lenses will discuss convex lens and concave lens. Convex lens and concave lens. Convex lens. So there are ray rules are there. Convex lens. So I'm taking this convex lens. Convex lens is also known as converging lens, whereas concave lens is known as diverging lens. Optic center f1, 2f1, f2, 2f2, f1 to f1, f2 to f2. So convex lens. So coming to concave lens, concave lens, concave lens, optic center f1, 2f1, f2, 2f2. So convex lens and concave lens, concave lens. You can check my Instagram page. I already given in the description. So you can check in the Instagram. Okay, so if you want to contact with me, or if you have any doubts, you can so send a message through Instagram. You can check once. So my Instagram page is available. So in the description, go and do like, share, and follow. Okay. So this is about convex lens and concave lens. Convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. Right now. Now, ray rules of convex lens will discuss. So there are three are there. Optic center f1, 2f1, f2, 2f2. Light rays passing after refraction passes through focus. Second one, light rays pass through here. Optic center f1, 2f1, f2, 2f2. Light rays passing through focus after refraction passes towards infinity. So light rays passing after refraction passes through focus. Light rays passing through focus after refraction moves towards infinity. Coming to third one, optic center f1, 2f1, f2, 2f2. Light rays passing through focus. Sorry, optic center. Light rays passing through optic center, no deviation takes place. It moves in the same path. Okay, so these are the three ray rules of convex lens. So ray rules of convex lens. Now we will see the concave lens. concave lens optic center f1, 2f1, f2, 2f2. Light rays passing after refraction moves away from it. After refraction, light ray will move away from the principal axis. Coming to the second one, so same thing I'm taking here. Optic center f1, 2f1, f2, 2f2. Light rays passing through focus. So here, after refraction become parallel to the principal axis. Coming to the third one, optic center f1, 2f1, f2, 2f2. Light rays passing through optic center, no deviation takes place. Okay, so it passes in the same direction. So these are the three ray rules of concave lens. Okay, concave lens. Next one, coming to the now image formations. We'll discuss about image formations. Optic center f1, 2f1, f2, 2f2, f2, 2f2. Object is at infinity. So I'm taking first one. So two light rays, one light ray I'm taking like this, another light ray. So after refraction, those light rays will meet at focus. Image will form at f2. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the second one. Optic center f1, 2f1, f2, 2f2. Object is placed beyond 2f1. Object is placed beyond 2f1. So here I am placing one light ray I am taking like this. So the light ray will passes f2 and 2f2. Another light ray is passing through optic center. Okay, so image will form between f2 and 2f2. So 2f2 here. Okay, so object is placed beyond 2f1. Object is placed beyond 2f1. Beyond 2f1. Image will form between f2 and 2f2. f2 and 2f2. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. Okay, coming to the next one. So third image formation we will discuss. for convex lens. Optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. So image also will form at 2F2. F2 and 2F2. Object is 2F1, image will form at 2F2, nature of the image is real and inverted, and same size. Coming to the fourth one, optic center F1, 2F1, F2, 2F2. Object is placed between F2F1 and F1. So how many light rays are required to form the image of the object? Minimum 2 light rays. So that's why I'm taking like this. And if you are passing through optic center, those light ray here they will meet beyond 2F2. Object is between 2F1 and F1. Image will form beyond 2F2. Beyond 2F2. Nature of the image is real and inverted, and size of the image is enlarged. Okay. So next one is object is placed. Fifth one. Optic center F1, 2F1, F2, 2F2. Object is placed at F1. So one light ray I am taking like this, it passes through focus. Another light ray is passing through optic center. Object is at F1, image will form at infinity, nature of the image is real and inverted, size of the image is highly enlarged. Coming to the sixth one is very important case. Very important case. Here I am taking optic center F1, 2F1, F2, 2F2. So object is placed between F1 and O. One light ray I am taking, it passes through focus. Another light ray is passing through optic center. If you are extending these light rays, the image will form here. Okay, so here. So image will form. So object is placed between F1 and O. Image will form same side of the object. Nature of the image is virtual and erect and enlarged. So this is about convex lens. So now we are discussing about concave lens. Enlarged. Now we will discuss about concave lens. I hope it is very clear, right? Next, concave lens. Check once. Object is at infinity, image will form at focus, nature of the image is real and inverted and highly diminished. Object is placed beyond 2F1, image will form between F2 and 2F2. Nature of the image is real and inverted and diminished. So nature of the image is real and inverted, size of the image is diminished. Object is placed at 2F1, image will form at 2F2, nature of the image is real and inverted, same size. Object is placed between 2F1 and F1. 2f1 f1 image will form beyond 2f2. Nature of the image is real and inverted. Size of the image is enlarged. Object is placed at f1. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Object is placed between f and o. Object is placed between f and o. Image will form same side of the object. So nature of the image is virtual erect and size of the image is enlarged. Is it clear? So that's enough. This is about convex lens image formation. Now we will discuss about concave lens. Concave lens image formation. So concave lens only two cases. Concave lens. Optic center f1 to f1, f2 to f2. Object is placed at infinity, so I am taking light rays like this, and here after refraction, so you can see this. So image will form at f1. Nature of the image is virtual and erect. Size of the image is highly diminished. Coming to the second one. Optic center f1 to f1, f2 to f2. Object is placed anywhere between optic center and infinity. Object is placed anywhere between optic center and infinity. One light ray I am taking like this, it reflects back. Another light ray passes through optic center. So here, if you are extending these light rays, those light rays will meet. So object is placed between O and infinity. Image will form between F1 and O. Nature of the image is virtual erect and diminished. Virtual erect and diminished. Nature of the image is virtual erect and diminished. Diminished. Okay. Now, power of convex lens is positive. Power of concave lens is negative. Oh my God. Power of convex lens is positive for power of convex lens is positive, whereas power of concave lens is negative. Power of convex lens is positive, power of concave lens is convex lens positive, whereas power of concave lens is negative. Okay, so power of convex lens is positive, power of concave lens is negative. The reciprocal of focal length is called power of lens. SI unit of power of lens is diopter. Reciprocal of focal length is called power of lens. SI unit of power of lens is diopter, right? So this is about light reflection and diffraction chapter. So I already daily I am posting the questions. So test series I started. You can check in the community post. So everyone, you can check in the community post. Daily I am posting the test series questions. So you can attempt those questions. And for grade 11 and grade 12 also I started. You can check once. Okay. So I hope it is very clear to all. And this is about the chapter. And related to questions, glass lab related one question will come, and uses are very important, sign conventions are very important, uses and sign conventions are very important. Glass lab question will come. And come to light reflection, loss of reflection, so and refraction also, loss of reflection and refraction also. And coming to the refract index relate absolute refract index and relative refract index, related to that also questions will come. And coming to one more, power related, and mirror formula and magnification, lens formula and magnification. So related to this also questions will come. So make sure that you are practicing all these questions, and you can check, you can watch my videos. So there are many videos are there related to CBSE Grade-10 physics. If you like the content, do like, share, and subscribe to Student the Brand. This is your Siva sir from Student the Brand. Thank you so much. Signing off. Thank you.